Welcome students. I hope you all are studying well during lockdown period. In this video, I am going to explain you about chapter 2 part 1 atmosphere. Let's begin. Dear students, let me give you an overview what you are going to learn from this video. In this chapter, you will be learning what is atmosphere, layers of atmosphere, which consist of troposphere, stratosphere, mesosphere, thermosphere, and exosphere, and importance of atmosphere. The Earth is the only planet in the solar system that supports life. This is mainly due to the presence of land, water, and air on the Earth. You already have some idea about the landforms and the water bodies. In this chapter, you will learn about the blanket of air that surrounds our planet. When Earth formed 4.6 billion years ago from a hot mix of gases and solids, it had almost no atmosphere. But as Earth cooled, an atmosphere formed mainly from gases spewed from volcanoes. The blanket of air that surrounds the Earth is known as the atmosphere. From the Greek word atmos, meaning vapor. The atmosphere extends more than 1,000 kilometers above the Earth's surface. It is held in place by the Earth's force of gravity. Let me give you an example of atmosphere so that the meaning of atmosphere will be more clear to you. Atmosphere is the ozone and other layers which make up the Earth's skies as we see it. Atmosphere is the air and gases contained inside a greenhouse. So my dear children, in the previous slide, you all have understood how the atmosphere has made of, what is the meaning of atmosphere with some examples. Now, in this slide, you will be learning about the composition of the atmosphere. As atmosphere is the blanket of air which makes up the atmosphere, which is a mixture of several gases. As this diagram shows how nitrogen makes up about 78% and oxygen about 21% of the total volume of the atmosphere. Carbon dioxide makes up about 0.03% and the remaining 0.97% includes other constituents such as argon, ozone, and water vapor. Some dust particles are also present in the atmosphere. Although the gases present in the atmosphere are used up in certain processes, they are also released back into the atmosphere in other processes. Thus, the composition of the lower part of the atmosphere remains fairly constant. With that, my children, you must be able to understand how the atmosphere constitutes of many gases. Earth's atmosphere is 78% nitrogen, 21% oxygen, 0.9% argon and 0.03 carbon dioxide with very small percentages of other elements. Our atmosphere also contains some water vapor. In addition to that, Earth's atmosphere contains traces of dust particles, pollen, plant grains, and other solid particles. Layers of the atmosphere. Now, my dear students, you will be learning the layers of the atmosphere. Actually, our planet's unique atmosphere contains five distinct layers. These layers are divided vertically on the basis of temperature. The different layers alternate between regions of increasing temperature and decreasing temperature with height. Let's move further to the another slide and see what five layers of the atmosphere consist of. Atmosphere has a series of layers, each with its unique specific traits. Moving upward from the ground level, these layers are named the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. The exosphere gradually fades away into the realm of interplanetary space. From the diagram, you can see troposphere starts from the Earth and it goes up to 10 km, as stratosphere starts from 10 km up to 50 km. Third level starts from 50 kilometers and up to 85 kilometers. That is mesosphere. When we go upwards, thermosphere starts from 85 kilometers up to 600 kilometers. And at the last, exosphere, it starts from 600 kilometers and it goes up to 10,000 kilometers. However, the boundaries between these layers are neither fixed nor well defined. The layers overlap and vary in thickness. Troposphere. Troposphere is the lowest and densest layer of the atmosphere. About 3/4 of the mass of the atmosphere is contained within this layer. The extent of this layer is about 18 kilometers above the equator, but only about 8 kilometers above the two poles. Actually, the troposphere acts like a blanket. It prevents days from becoming very hot and nights from becoming very cold. Within the troposphere, the temperature decreases as we move up. Most of the water vapor, clouds, and dust particles of the atmosphere are found in this layer. The troposphere gets its name from the Greek word tropos, which means turning. This is because all the weather changes that we experience take place in the troposphere. The upper limit of the troposphere is marked by the tropopause, where the general decrease in temperature with altitude stops. Basically, The tropopause is the boundary in the Earth's atmosphere between the troposphere and the stratosphere. Although variations do occur, the temperature usually declines with increasing altitude in the troposphere because it is mostly heated through energy transfer from the surface. Thus, the lowest part of the troposphere, that is, Earth's surface, is typically the warmest section of the troposphere. The troposphere basically contains roughly of about 80% of the mass of Earth's atmosphere. So with that, let's move on to the another layer of atmosphere. Stratosphere. Stratosphere is the second layer of the Earth's atmosphere. The stratosphere lies above the troposphere and extends to about 50 kilometers above the Earth's surface. It lies above the troposphere and is separated from it by the tropopause. This layer extends from the top of the troposphere at roughly about 10 to 12 kilometers above Earth's surface to the stratopause. A part of the stratosphere is known as the ozonosphere, as it has the maximum concentration of ozone in the atmosphere. Ozone protects us by absorbing the harmful ultraviolet rays of the sun. The ozonosphere becomes quite warm by absorbing these rays. The ozone layer is contained within the stratosphere. It is mainly located in the lower portion of the stratosphere, though the thickness varies seasonally and geographically. About 90% of the ozone in Earth's atmosphere is contained in the stratosphere. The atmospheric pressure at the top of the stratosphere contains the ozone layer, which is the part of Earth's atmosphere that contains relatively high concentrations of that gas. The stratosphere defines a layer in which temperatures rise with increasing altitude. The rise in temperature is caused by the absorption of ultraviolet radiation from the sun by the ozone layer, which restricts turbulence and mixing. The temperature in stratosphere profile creates very stable atmospheric conditions. So, the stratosphere lacks the weather-producing air turbulence that is so prevalent in the troposphere. Consequently, the troposphere is almost completely free of clouds and other forms of weathers. Mesosphere. The mesosphere is the third highest layer of the Earth's atmosphere, occupying the region above the stratosphere and below the thermosphere. It extends from the stratopause at an altitude of about 50 kilometers to the mesopause at 80 to 85 kilometers above sea level. It extends to about 80 kilometers above the Earth's surface. In this layer, the temperature decreases with the altitude and falls as low as -85 degrees Celsius. As the temperature drops with increasing altitude to the mesopause that marks the top of this middle layer of the atmosphere. As I already said before that the temperature decreases with altitude, that means it is the coldest place on earth and has an average temperature around minus 85 degrees Celsius. Meteors can be found in this layer, that is mesosphere. A meteor as a shooting star or a falling star is the visible passage of a glowing meteoroid through the Earth's atmosphere. Meteors entering the atmosphere usually burns up in the mesosphere. Meteors is too high above Earth to be accessible to jet-powered aircraft and balloons and too low to permit orbital spacecraft. Thermosphere. The thermosphere is the second highest layer of the Earth's atmosphere. It extends from the mesopause at an altitude of about 80 kilometers up to the thermopause at an altitude range of 500 to 1000 kilometers. Above the mesosphere lies the thermosphere, which extends to a height of above 450 kilometers above the Earth's surface. The lower part of the thermosphere from 80 to 550 kilometers above Earth's surface contains the ionosphere. Ionosphere will be explained to you further in the video. The temperature of the thermosphere rises rapidly with altitude in this layer. Unlike the stratosphere beneath it, wherein a temperature inversion is due to the absorption of radiation by ozone. The temperature of this layer can rise as high as 1500 degrees Celsius. Though the gas molecules are so far apart that its temperature in the usual sense is not very meaningful. Although the thermosphere has a high proportion of molecules with high energy, it would not feel hot to a human in a direct contact because its density is too low to conduct a significant amount of energy to or from the skin. This layer is completely cloudless and free of water vapor. The International Space Station orbits in this layer between 350 and 420 kilometers. Exosphere. Exosphere is the outermost layer of the Earth's atmosphere, that is, the upper limit of the atmosphere. It extends from the exobase, which is located at the top of the thermosphere at an altitude of about 700 kilometers above sea level, where it merges into the solar wind. This layer is mainly composed of extremely low densities of molecules. The atoms and molecules are so far apart that they can travel hundreds of kilometers without colliding with one another. Thus, the exosphere is no longer behaves like a gas, and the particles constantly escape into space. The temperature in the exosphere is very high. As you might imagine, the air in the exosphere is very thin, making this layer even more space-like than the thermosphere. In fact, air in the exosphere is constantly, though very gradually, leaking out of Earth's atmosphere into outer space. There is actually no clear-cut upper boundary where the exosphere finally fades away into space. Different definitions place the top of the exosphere somewhere between 1 lakh kilometers and 2 lakh kilometers above the surface of Earth. The latter value is about halfway to the Moon. So, my dear students, till here I have completed the 5 layers of atmosphere. On the screen, there is a general note which is going to tell you about the ionosphere. Ionosphere is the layer in the atmosphere in which the molecules of the atmospheric gases are broken into charged particles called ions. This layer is called ionosphere. In the diagram itself, you can see that ionosphere starts at about 50 kilometers and it extends up to 1000 kilometers above the Earth's surface. Basically, the ionosphere is a region of the atmosphere that is ionized by solar radiation. It is responsible for auroras. During daytime hours, it stretches from 50 to 1000 kilometers and includes the mesosphere, thermosphere, and some parts of the exosphere. However, ionization in the mesosphere largely ceases during the night. So, auroras are normally seen only in the thermosphere and lower exosphere. Generally, it reflects or sends back radio waves towards the Earth and thus helps in radio transmission. So, my dear students, now in this presentation, you will learn about why is the atmosphere important to our life. Actually, the atmosphere protects life on Earth by absorbing ultraviolet solar radiations and reducing temperature extremes between day and night. It helps to protect living organisms from genetic damage by all these radiations. Now, let's begin why is it important and we'll be able to understand some points. Let's examine some of the points why an atmosphere is important for the living beings. First, the atmosphere gives us the oxygen that we breathe. What we are living for and what we need oxygen. And oxygen is given to us by this atmosphere only. Second, carbon dioxide in the atmosphere helps plants to manufacture food in the presence of sunlight. Third, The atmosphere stops the sun rays from heating up the earth beyond a certain level. Also, the carbon dioxide in the atmosphere does not let too much heat escape from the earth. So, the atmosphere prevents the earth's surface from becoming too hot or too cold. Fourth, the ozone in the atmosphere protects us from the harmful ultraviolet rays of the sun. Fifth, nitrogen is required in various forms to keep the soil fertile. It also helps in the growth of the plants, which gives us food. Sixth, the atmosphere gives us rain, snow, and wind, which are essential elements of weather. The water vapor in the atmosphere causes rainfall and snowfall. Wind is nothing but the horizontal movement of air. Seventh, the atmosphere prevents most meteors from hitting the Earth's surface. My dear students, here I am concluding Chapter 2, Part 1 of Geography, Atmosphere. I hope you all must have understood the chapter thoroughly. Before that, you just need to remember all the points which I have covered in the video. Let me brief you about it. Atmosphere is the blanket of air surrounding the Earth. Its five main layers are the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Air is the mixture of gases that makes up the atmosphere. It has about 78% of nitrogen, 21% of oxygen, 0.03% carbon dioxide, and 0.97% other constituents such as argon, ozone, and water vapor. Atmosphere is very important essential element for life on the earth for the living beings. Dear students, on the screen there is exercises which you need to submit it to your concerned teacher. First exercise is A. Fill in the blanks. First, dash gas in the atmosphere protects us from the harmful ultraviolet rays of the sun. Second, the ionosphere helps in radio communication as it contains dash. Third, dash is the innermost layer of the atmosphere. Fourth, meteors entering the atmosphere usually burn up in the layer called dash. Fifth, dash is required in various forms to keep the soil fertile. Here is an exercise B. Answer the following questions. First, distinguish between the troposphere and tropopause. Second, in which part of the atmosphere does the ozonosphere lies? Third, what is the atmosphere? Fourth, why the atmosphere is important? Fifth, name the five main layers of the atmosphere in order of distance from the ground. These are some of the assignments which you have to do and submit to your concerned teacher. Stay home, stay safe. Thank you and have a nice day.